Yes, Eugene, you are here and you are an attendee. I am promoting you to a panelist. If you can click accept to the promotion. Yes. Okay, cool. Great to see you here, Eugene, just on time. All right, thank you everyone for joining this session, session 22D, themed around materials and innovative manufacturing. I am your session chair, Kevin, from Monash University in Australia. And since I am joining in from one of the over 500 Indigenous nations that make up Australia, as we begin, I would like to acknowledge the First Nations people on whose lands we are joining from today. I would like to pay respects to elders past, present, and emerging. I'd like to remind you that each presentation will be 10 minutes followed by 5-minute question time. So please type your questions up into the Q&A function at the bottom of your screen. And without further ado, I'd like to introduce our first speaker, Eugene from CY Surgery in France for his project titled Vital Drone. So whenever you're ready, Eugene, please share your screen and start.
Yes, tell me please, how do you hear me?
Very well.
Without any noises. Okay, great.
No
Because
noise
okay. Yes. Hello, everyone. My name is Eugene Voronov, and I am presenting CY Serge Paris University, CY Tech. And today I want to show you my research, which I did during last 10 months. And this research, part of my project, it's drones, autonomous navigated drones for agriculture segment and for phenotyping for laboratories. Today I want to show you my algorithm, vision-based simultaneous localization and mapping algorithm for SSL, solid-state LiDAR or infrared cameras, working on small single-board computers for drone. So actually, a SLAM problem, it's a computational problem, and that means that if you try to run any existing algorithm on a small computer, it won't be working good, or it won't be working at all, because you should have a lot of powerful processing time to create a map based on visual odometry, which you can get from your camera, from your robot wheels, or another devices and other sensors. And my idea was to develop some algorithm for my needs, which will be following next requirements. This algorithm should be optimized for lower power computers, as a Raspberry Pi or Jetson Nano, which cost less than 200 euro. Minimize camera drift. That means that when camera moving, you should to control it, and your camera shouldn't to get lost where's actually what's happening around the camera. Minimize accumulation errors over time, and this algorithm should reconstruct 3D space around robot, around in indoor space, and should to create occupancy map. This is need for path planning. My technical resources which I used, it's solid state LiDAR camera, as you can see on the left side, and on the bottom you can see tracking camera with GPU processor, which really good do visual odometry. And on the second side, you can see infrared camera, which working with RGB depth image, and it's very good to this algorithm too. For computer, I use Raspberry Pi for tests and NVIDIA Jetson Nano, 4 GB RAM. My algorithm worked on under ROS, robotic operation system, plus WebSockets. WebSockets we need just to transfer data from Raspberry Pi to some web service to the cloud. RGB depth, we are starting from this, and LiDAR camera return us point cloud, and the RGB depth camera return us just RGB depth image, which we can convert to point cloud too. How it looks like, RGB depth image looks like this. Then some objects which are really close to us, it's have little bit different color diapason, and we can use it for our needs. After that, transform this RGBD image to point cloud and put it to the algorithm. For visual odometry, we are using special camera which already return us pose of the camera. That means that if camera will be on the drone or in another robot, we will be know which engine right now has this camera. That means has robot. How it's actually working? It's working like this. I'm so sorry, little mistake. Actually, it's working like this. We have some path here, and after that, just camera following, and we can see this trajectory. And it's pretty like small mistakes this camera can do, and that means that we can use better for our needs. After that, we're using camera IMU data and flight controller IMU data. But in flight controller, actually, we have magnetometer and barometer too. After that, we should merge this data, velocity, acceleration, and other stuff which we already have and we are using some open source project that's Madrid filter, and put all this data, include odometry too, to the external Kalman filter. It helps us to union data from any sensors and get optimized odometry. That means pose of our robot. Algorithm include several nodes. It's point cloud processing node, feature structure, which calculate the distance, Euclidean distance between the points, the small clouds. And after that, we can filter it. We can, if we want to concentrate on some objects and it's pretty close to the camera, that means that we can take less distance between points and take these points and put it to our final map. After that, to optimize, save some memory on our computer, we transfer this data to the cloud through WebSocket, and we don't using any memory in our computer. And this is really give us really great performance. And after that, we can use this this cloud, point of cloud, this our map, to any devices. For test environment, I use my room. On the left-hand side, you can see the table with computer, with map, and the drone. And for the right-hand side, you can see the green wall, these plants, which I'm using for phenotyping testing. This is small drone. This is and I'm using it for laboratories and some phenotyping stuff. How it's actually working? This is first version of algorithm. Here, like I still have some problem with optimization and with the resolution. But actually, this is whatever we need for drone. And after that, for the next step, we put this data to some point cloud net, so some deep learning neural network, and we can using this model to other steps like predict some region of interest and so on. And this is more detailed point cloud, which we can using the same stuff if we need it. If you need something a little bit detailed, we can do it. Like just to be, that camera should be a little bit closer to the interest object. And yes, and here this little bit different settings. It's give us a little bit more or less distance between points when the camera too close to the interest objects too. I'm use this for my project. It's a drone for farming. This is not. This is pre-alpha version. Yeah, I'm using this drone just for testing. But the main idea to take a cloud platform for farmers, for researchers who work in laboratories, and they can, using this point of cloud, for explore fields, determine the growth of plants, determine, some illness, pathologies of plants. And because we have a laser camera or infrared camera, we can measure the length of plants, we can measure, angle of tree, and so on. Yes, thank you so much. I'm open for any questions right now, and you can send it to me by email or call me.
Thank you so much, Eugene. That was an amazing talk. Very, very interesting. Let's see if the audience has any questions. If you do, please type them out into the Q&A function at the bottom of the screen. We have 4 attendees currently, so if you'd like to share a question, please do. In the meantime, I guess I will ask a question. What do you think about the cost of this technology? Is it something that we can use practically right now?
Yes, actually, I really did big research, and I tried to use something what I can use and don't develop something new for me, because actually 10 months ago I didn't know how to develop it, but it's pretty interesting. And I know that big companies like DJI try to do something like this, and but they're using it just for outside, for some farming and so on. But yes, I think if it will be more optimized, and it will cost a little bit less, and it will be working on some lightweight computer better than right now, I think we can use it for any autonomous navigations, robots, and so on, indoor. Yeah, so some logistic drones which working outside a factory, something like this. We can measure. We can actually get the real volume of the object if we will know his, his width, height, and so on. Yes, and I think that laser technology cameras, it's a good one, because still we can measure everything if we know how it's work, and we can like write some special algorithms for it. We can measure and weight any any boxes on the logistic factories and logistic companies, and that's cool. That can optimize a lot of stuff around us.
Cool, yeah, thank you for your detailed response, Eugene. We have a question from Craig. Was your research impacted by any of the pandemic restrictions, or did you have to rethink the way you were going to do things? Would you do anything differently?
Can you please repeat the question?
Yeah, so the question really was your research impacted by COVID-19?
Yes, actually, I thought about to do something like this, but my big passion, it's to be molecular biology, but not right now. Maybe in 10 years I will try to achieve it, and of course, but I really wanted to do something like this, then create some special test for express test for these. But I understood that my knowledge is not so big right now, and I hope that in future I can do it. And yes, thank you for question. It was really great, but it's still my passion, and it's still my dream. I will try to achieve it.
Cool. Just another quick question from the audience. Are there any significant differences in this process of mapping between using a drone and a land mobile-based robot?
Yes, I think, when you're doing something like this, and when I first time ran my drone it was outside and it's crashed. Of course, I feel myself not really good, but after that, I did some research, and again, and I have found that it was not a pretty difficult mistake, which I did. It was in hardware. I fixed it, And when I first time ran it in outside my apartment, and it wasn't a big drift, and so I was really happy. And the next step, which I really want to make with this algorithm, is like implement path planning, using this data, this cloud of points, and for drone orientation in defined space where it will be defined.
Oh, thank you. Just one last question. I think we can fit this in. How would you believe you could improve this prototype in the coming months?
Improve this prototype to yes. I think first, what I really to do is that I hope it will be in the next week. I will implement some methods to calculate distance, Euclidean distance, a little bit better. And for not close objects, it will be a little bit more than right now, because right now we have a lot of noises if we are doing something really close, really calculate points with a small distance for the really further. Sorry, a little bit pretty long from us. And it will be more detailed when it will be front of us, and it will, as in a computer game, if you don't see something, it's a little bit blurred, something like this. And it will, of course, it will help to optimization. And after that, right now working on cloud platform. This is web interface, which help to use this drone simple people or simple laborants who don't know anything about technologies, and it will be easier for them to use it.
Great. Thank you very much for such a great presentation and detailed answers to these questions. I think we will now move on to our next presenters. I would like to introduce our next presenters, Brintha and Kimberly from Monash University in Australia, for their project titled 3D food printing. So Eugene, if you could unshare your screen and let Brintha and Kimberly share theirs,